Hello and welcome to another lecture about data structure. Today we will discuss about queue, a linear data structure in which operations follow specific order. First in, first out is the specific order that is the main structure of the queue. There are mainly 6 operations to perform different actions on the queue. Initially we have 2 pointers and we will discuss about them later on this video. The first main operation that we're going to discuss about is enqueue. Enqueue adds element at the rear of the queue. The next one is dequeue. Dequeue removes elements from the front of the queue and in fact removes the frontmost or oldest element in the queue. Is empty returns true if the queue is empty, and is full returns true if the queue is full. Sometimes when the queue has reached to its allocated capacity, then adding elements is not possible. Pick returns the value of the front of the queue, and we can get that element. And finally, size returns the number of the items within the queue. So let's have a closer look at our illustration. Initially, we have 2 pointers, rear and front. Rear tracks the newest inserted element, and front will track the oldest inserted elements. So the first operation is enqueue, that adds elements to queue. We are only allowed to add items from rear and remove items from front. Let's to see how dequeue works. As discussed earlier, removing is only possible from the front of the queue. To just explain it in detail, we need to talk about 2 methods. One is to remove the elements at the front position and then move other elements 1 position forward. Or in other words, we need to shift elements, and in this approach there is an overhead because every time that we remove an item, then we need to shift all elements 1 position. So let's to have a quick pause on what we have on the screen and show you another method. As is observed in this method, we remove the element from the front of the queue, and instead of shifting all elements, we only need to move the front pointer to the next element. However, this approach will reduce the capacity of the queue by 1 space each time. The next operation is empty, and surely it returns false because we have items there in our queue. And the next operation is full, and it returns false because we can still put items there in our queue. The next operation is pick, that will return the oldest item, or in other words, it will return the value of the front of the queue. And finally, size will return the number of items in our queue, that is equal to 3. In fact, it returns the number of elements present in a queue container. Thanks for watching this video.